a universe inconceivably large and dark and sparsely populated with little islands of starlight.
Sending satellites to distant parts of space is useful. However, it helps to keep an eye in space in the form of telescopes. And compared to those telescopes on Earth, the space telescopes can see more because light in space is not distorted by shifting pockets of air, unlike the Earth's atmosphere, which is why stars appear to twinkle when viewed from the ground. And the Hubble telescope has observed locations more than 13.4 billion light-years away, meaning that it has seen light that existed in the universe 13.4 billion years ago.
A telescope is a time machine, using light to transport us into the past.
This is Space Journey 101, and today we will look at the Hubble and James Webb telescopes. The Hubble Space Telescope was launched into low Earth orbit in 1990 and remains in operation. It was named after the astronomer Edwin Hubble. The Hubble Space Telescope is known for its ability to provide incredibly detailed images of distant objects in the universe.
With the Space Telescope, we'll be able to look to much greater distances and therefore much further back into time. In fact, much closer to the creation of the universe itself.
It has helped scientists make numerous important discoveries, including the existence of dark energy, and helped astronomers gauge how much time had passed since the Big Bang.
With the Space Telescope as our time machine, we can look back almost to the beginning of time to see how our universe evolved.
The telescope is approximately the size of a school bus and is equipped with a 7.8-foot mirror that allows it to collect light from distant objects. It is capable of observing objects in visible, ultraviolet, and infrared light, which allows it to study a wide range of celestial phenomena, although it can only see each kind of light one at a time. Since its launch, the Hubble Space Telescope has made more than 1.5 million observations and taken more than 1 million images. It has been visited by space shuttle missions a total of 5 times for servicing and upgrades, allowing it to remain in operation long beyond its original expected lifespan. However, it did have some teething problems. Hubble was a $2.5 billion scientific endeavor, and its first photo was only 50% sharper than what an existing ground-based telescope in Chile could capture. Engineers at NASA scrambled to improve image quality, but soon discovered that Hubble's major flaw was its main mirror.
The first images from Hubble were frankly a little disappointing. They were not as sharp and crisp as we had hoped. It turns out that the mirrors had a slightly misshapen form.
A manufacturing error resulted in spherical aberration in the mirror.
A lot of people feel we don't need the Star Wars defense system anymore. Hey, I think we should keep it, if only to shoot down that Hubble spacecraft and put this thing out of its misery. Huh? Yeah. Oh, that's what I think.
But we're pretty optimistic that we can take out all the aberration with the second wide field camera and get us back to the original specification.
As a result, NASA launched a repair mission in late 1993.
And we have liftoff of the Space Shuttle Endeavour on an ambitious mission to service the Hubble Space Telescope.
A 7-person crew flew to Hubble and spent 5 days installing corrective optics and new instruments.
Houston, Endeavour has a firm handshake with Mr. Hubble's telescope.
Hubble was the first spacecraft designed by NASA to be serviced and repaired in space. The Hubble Space Telescope has been an invaluable tool for astronomers and has contributed greatly to our understanding of the universe. It has helped us to see further and more clearly than ever before, and its legacy as one of the most important scientific instruments of all time is well deserved. The James Webb Space Telescope is a space telescope that is the successor to the Hubble Space Telescope. It is named after the former NASA administrator James Webb. The James Webb Space Telescope is designed to be more powerful than the Hubble Space Telescope and is capable of observing distant objects in the universe with even greater detail. It is equipped with a 21-foot, 4-inch primary mirror, which is almost 3 times the size of the mirror on the Hubble Space Telescope. This allows it to collect more light and provide even sharper images of distant objects. In addition to its large mirror, the James Webb Space Telescope is equipped with a variety of advanced instruments, including a near-infrared camera, a near-infrared stenograph, and a mid-infrared instrument. These instruments allow it to study a wide range of celestial phenomena, including the formation of galaxies, the birth of stars, and the detection of exoplanets. All this technology needs to be kept below -370 degrees Fahrenheit to function correctly. Space is actually colder than the telescope's working temperature, but only for objects that are not illuminated by the sun. The James Webb Telescope has a sun shield made of 5 layers of Captain E with aluminum and doped silicon coatings to reflect the sun's light and keep it from interfering with the highly sensitive instruments. Because the telescope must always remain in the shade of the sun shield, it can only see 40% of the sky at once. The James Webb Space Telescope was launched in December of 2021. It is placed in an orbit approximately 1 million miles from Earth, which allows it to observe distant objects without being affected by the distortion caused by Earth's atmosphere.
Constantly shifting layers of air of different densities bend light back and forth. Atmospheric turbulence imposes a fundamental limitation on a telescope's ability to see clearly 2 objects close together in the sky. At times of bad seeing, stellar images waver like candle flames in a gentle breeze. The space telescope will be out where the images are completely quiet.
It does not, however, orbit the Earth. Because it must always be shaded from the sun's light, it has been placed in the sun's orbit in a position known as the second Lagrange point, or L2. A Lagrange point is a unique location in space where one object can easily remain relative to 2 celestial bodies. In this case, the James Webb Telescope is essentially able to maintain a fixed relative position to Earth in orbit around the Sun, with only the occasional need to adjust its motion. Overall, the James Webb Space Telescope is a major advancement in astronomy and will help us to better understand the universe and our place in it. It will provide us with new insights into some of the most fundamental questions in astronomy and will pave the way for many exciting discoveries. In the next episode, we will talk about the future of space. Stay tuned.